Hi guys, so we are starting a new unit, so we're doing Unit 11 for Solutions. And so what I want you to do is go ahead and take out your notes packet, and so we can do homework pages 1 through 2. Okay, so remember, for the top we need to classify whether it's a pure substance or a mixture. And so a pure substance can be elements and compounds, while a mixture is a physical combination of two or more pure substances. Okay, so a good way to know if you're dealing with a pure substance or a mixture, so notice pure substance, there's an actual chemical formula for it. And so if you can find the formula on your periodic table, then odds are it is a pure substance. Okay, so for example, a cup of coffee. Well, I can't find a cup of coffee on my periodic table, so therefore that would be a mixture. Oxygen, also known as O2, would be a pure substance. Glucose sugar, well, I have a chemical formula for sugar, and so that also would be a pure substance because it's a compound. Carbon dioxide, again, would be a pure substance. Okay, so I want you to go ahead and fill in numbers 8 through 14 on your own. And let's go ahead and move to the bottom box. And so numbers 15 through 26, these are all going to be mixtures. However, I want you to indicate whether it's homogeneous or heterogeneous. Okay, so if it's homogeneous, we have the definition right here. And so it says that it looks the same throughout the sample. Okay, so it's going to be the same color. You can't tell that it's multiple compounds in one. While heterogeneous appears to have different parts or layers when observed. Okay, so you can see the different substances that are within the mixture. Okay, so for number 15, already done for you. So 2% milk from the store. So if you were to look at a gallon of milk, you would see that it's all the same color. You can't tell that it's multiple parts within it. And so that would be a homogeneous mixture. Well, mint chocolate chip ice cream would be a heterogeneous mixture because you would see the different chunks of chocolate within the ice cream. Italian dressing, well, that would be a heterogeneous mixture because if you look at the Italian dressing, it has this sort of off, like yellow color, and then you can see like the different like spices and stuff that is within the dressing. Okay, white school glue. Okay, so if you look at Elmer's glue in a bottle, it is just all white, and so that would be homo. Soil, however, if you looked at dirt, you can see various different grains within the soil, and so that would be hetero. Okay, if you looked at tap water, so if you just run water in your faucet, it all looks like water, and so that would be homo. Same for black coffee. If you were to make a cup of coffee, you would see all of the liquid is brown, and so that also would be homo. And so I want you to go ahead and try and fill out the rest, so 22 through 26 on your own. Alright, and then these bottom questions. It says, which material is a mixture? Okay, again, the way you can tell the difference if you have a mixture or a pure substance, remember pure substances, we can write chemical formulas for it. And so we have a chemical formula for that one, for propane, chemical formula for gold, and a chemical formula for carbon dioxide. However, we don't have a chemical formula for seawater, so therefore that one would be my mixture. Alright, so this one, number 28, says which material is a pure element? Okay, so a pure element is an example of a pure substance. So I already know seawater cannot be it, because seawater is a mixture. However, the way you determine if you have an element is it's usually found as a single atom. And so when we look here, propane, well, that's composed of C3 and H8. So that is not an element, it is a compound. So that can't be it. Gold, also known as Au on our periodic table, well, that's one element by itself, so that's probably our answer. And if we look at carbon dioxide, it has CO2. Well, it has two different elements, and so I know that is a compound, and so my answer would be C. Okay, so I went ahead and turned the page over, so now I'm on page 2. And so at the top, it says, which best describes the sample to the right? Alright, so if we look at the right, we have iron and sulfur. Okay, so these are both examples of elements. And so since we have two or more elements and they're not combined, so we have a mixture of elements. Okay, number 2, which best describes the sample to the right? Alright, so if we notice, it has one type of element with two other elements bonded to it. And so I know that to be a compound, and I have 5 of them, and so that would be I have 5 of them, and they are all of the same type of compound, and so that's just a pure compound. Okay, if I had different types of compounds within here, then I would have a mixture. Alright, number 3 and 4 are a little tricky. And so I'll let you try number 3 on your own, but I'm going to go ahead and do number 4 with you. And so number 4 says, which particle diagram above best represents a mixture of elements? Okay, so I automatically know B cannot be my answer because those are compounds. D cannot be my answer because it's a mixture of compounds and elements. And A is a mixture of compounds. And so therefore, my only choice could be C. So notice they have two elements bonded together, but if you remember and you look back at your notes, it also says that some gases exist at 2 atoms bonded together. For example, oxygen gas. And so my answer would then be diagram C. Okay, so along with your notes, you should be able to answer numbers 5 through 12. However, I just want to hit some points with you. And so a solute would be the smaller amount. Okay, so it is what is being dissolved, while a solvent is your larger amount and it does the dissolving. Okay, and then also for electrolytes, remember electrolytes are usually ionic compounds. Okay, and so an ionic compound would be a nonmetal plus a metal. Okay, so ionic compounds are usually what electrolytes consist of.